Hello. So, I hope you can hear me. Um, so again, sorry for yesterday. I was late by almost an hour to the stream, but today I am bang on time. So we are just waiting for about 2 more minutes for the stream to get started. Uh, but yeah, actually, just need to make sure my volume is coming through because it sounds like it isn't. As far as I can see, it should be coming through. So hopefully that's working, and if it's not, I will feel kind of disappointed at the end of today. Not too sure how else to check this. I have 1 minute to make sure this works. So what I'm doing right now is I am creating the template for putting my input in the way that I have done yesterday because it seems to just work a little bit better. It keeps my file a little tidier. So hopefully that works. I don't have time to check my mic, so I'm just hoping that it works. And if it doesn't, then I'm just going to be very sad. All right, the challenge is up. Let's see what's going on. Okay. Okay. So there are trees and there are other things that we can't see. The same pattern repeats many times to the right. Okay. Start on the open square in the top left corner, you need to reach the bottom. This polygon can only follow specific slopes. you follow a cheaper model that only prefers rational numbers. So start by counting all the trees you would encounter for the slope right, 3 down 1. For a starting point, check the position that is right 3 down 1, then check the position that is right 3 down 1 from there, and so on until you get past the bottom of the map. Locations you would check in the above examples are marked with 0, and X is where there is a tree. In this example, traversing the slope would cause you to encounter 7 trees. Starting at the top left corner of your map, following a right slope, right 3 down 1, how many trees would you encounter? That should be fairly straightforward. Oh, that's a very long map. Right, I'm having bad thoughts about this. Oops. So again, I'm doing my little trick to pre-format my input so I don't have to actually parse it or do anything. And then here I'm just checking that my input actually works. So I'm setting up my command to automatically run my program every time. Cool. So it seems like I have it. Now I know that each input is the same length. And so because I know each input is the same length, what I can do is do some sort of, well, you know what, I'll probably just save it. Save it to a thing, const mod equals, yeah, input 0.length. So basically what the question is saying is I need to go down every single line, but count the number of trees I encounter as I go down. And so 31. So as the pattern repeats, all I have to do is, if I ever go past 31, all I have to do is basically loop back to 0 and go again, right? And so let's see. We start with, so we're going to loop over every input for const row of input. For every line of the input, what are we going to do? We are going to check if, so write 3 down 1, right? Okay, so write 3 down 1 means we add 3 every time. So what we want, we can't do it this way. We need an index. Input.length I++. We need to say that the cell that we're checking is going to be I times 3 modulus mod. Const offset equals that. And so what we want to check is let trees equals 0. We say if input I, and then we index into that row at offset. If that is a tree, then we increase the number of trees we've encountered. At the end, trees, we just log up the number of trees we've encountered. That should work. So apparently we've encountered 294 trees. That sounds a bit high, but we'll chuck it in and see what happens. We got it right, 600th on this, so let's go to part 2. To check the rest result, you need to minimize the probability of sudden arboreal stop hitting a tree. Determine the number of trees you encounter if, for each of the following slopes, you start at the top left corner and traverse all the way down to the bottom. This is like we already checked. In the above example, these slopes will produce 2, 7, 3, 4, and 2. Multiply together and you get 3, 3, 6. What do you get if you multiply together the number of trees encountered on each of the slopes? So there are a couple ways to do this, but what we'll do is we'll do it like this. We'll const slopes equals, and we will check right is 1, down is 1, and so on, and we have all the patterns, right? We have 3 and 1, we have 5, 5 and 1, 7 and 1, and we have 1 and 2. So now we have parameterized this thing. Function check trees. We have right, down, like that. Return trees. So now we just put this into a function where the function will do different things based on the input. So right is the number, so this is down, plus equals down, and this times here is right. Return trees. So what we can now do is console.log params is for each one. We can say these are the params, and number of trees we hit is tree count. Is it check trees? I called it. Slope dot right, slope dot down. Okay, I need to fix my spelling here. Cool, and it says multiply all these numbers together. So const yeah, I mean there are different ways to do this, but we'll do it like this. Trees equals that prod times equals trees, and we go console.log prod. That is our product. We're going to pop that in here. And that is it. We got 400. So it was quite an interesting problem. I couldn't really, again, I am so bad at explaining things. And I don't know if my audio is not working because it feels like it's not. So I'm gonna leave it there. Yeah, if you know programming, you know what I did. If you didn't, this was actually a really good example of how to parameterize your inputs, right? So doing the same problem, but checking it for different diagonal slopes. One of them was going straight diagonal down. One was checking it for a bit more of a slope, and then more of a slope, more of a slope. One was a very, like different gradients along this slope. And then using that mod trick to loop back around so we don't have to keep manually stretching out the array. Yeah, so that was a really fun problem. It wasn't too tricky, and it seems like we will hit the fewest trees if we go right 1 and down 2, so that's the route we're going to take. Hopefully, if this video audio doesn't work, I will have that fixed by tomorrow. Good to have you here.